don't want to be anyone student is confused during the study of this chemistry, which is applied for which is applicable for the engineering, special branch for the engineering. Okay, so one can go through that. Okay, most of the things are there. All the basics are concerned basic things are also there. You can go through it, and we will have discussion. Also, we will have the doubt clearest classes. Okay, so if somebody has, or if one or two, three doubts are there, then we will take in classes only. But there are multiple. What we are saying, what I am saying, doubt regarding basics. Okay, doubt regarding basic, which is not in the syllabus part. Okay, but I have mentioned in the slide, and whichever is not mentioned in the slide, that also you can ask. Okay, whichever is not mentioned, but that is basic part to understand this mechanism part, or any analytical part. Okay, that also you can get the query if you have concern with that. Okay.
Okay, sir. Sir, bond
Yes.
breaking sir endothermic process क्या है sir?
Bond breaking. You can see.
Yes,
I will show you this one.
और सर बॉन्ड फॉर्मेशन में सर एनर्जी रिलीज क्या होता है सर बता.
Can you see this slide? Can you see this slide?
सर अभी नहीं दिख रहा है सर.
Okay, one second. Okay. Okay.
Yes, sir, दिख रहा है सर.
This one, okay. I think you know the Gibbs free energy delta G. Delta G, total energy change in the reaction course. Total energy change in the reaction course. What are the things are there which is involved in it? One thing is your delta H. Okay, change in your bonding energies. Okay, change in your bonding energy and change in disorders. Change in disorder, or you can say delta S. T delta S. Okay, T is nothing but your temperature. Okay, and we are taking temperature in Kelvin temperature. Okay, unit as a Kelvin temperature. And here you have the Gibbs free energy, or total energy involved in the reaction. And your question is that why bond breakage requires the energy, or it is endothermic, right? Isn't it?
Yes, sir.
Okay. While doing any reaction, see here you have example. Okay. You have this molecule A and B. What will happen with respect to your delta G? What will happen? Your enthalpy will increase or decrease. You are providing energy to break the bond. To break the bond, you are providing energy. Why? Suppose anything is there and you have to break that. Okay, any stick is there. Okay, any stick also there. Wooden stick is there. Okay, that also requires energy. Without energy it will break automatically? Will it break automatically?
No, sir. No,
No
sir.
sir. Obviously not. सपोज आपके पास एक लकड़ी है और उसको तोड़ना है, तोड़ने के लिए आप क्या कर रहे हो? यू आर अप्लाइंग फोर्स, यू आर अप्लाइंग एनर्जी। ओके, जब आप उसको एनर्जी दोगे, उसको तोड़ने की कोशिश करोगे, देन यू आर बेसिकली व्हाट यू आर डूइंग, यू आर अप्लाइंग द फोर्स। फोर्स मींस एनर्जी इन द फॉर्म ऑफ फोर्स। ओके, देन व्हाट विल
Yes, sir.
हैपन एट द एंड? ऐसा होगा कि आप बस एक्स वाई जेड आप फोर्स दोगे और वो टूट जाएगा? नो, it will reach to the, when it will reach to the threshold point, then it will break. ऐसा है क्या? एक कांस्टेंट फ्लो, मतलब एक एक्स वाई जेड फोर्स जो है उतना काफी है सभी स्टिक तोड़ने के लिए?
नहीं, सर।
सभी स्टिक, वुडन स्टिक तोड़ने के लिए काफी है क्या?
नो, सर।
नो,
नहीं,
ठीक है।
सर।
एक एक अगर मान लो लकड़ी का स्टिक है, उसको तोड़ना है हमको, तो हो सकता है उसके लिए थोड़ा फोर्स लगाना पड़े एक्स। उससे बड़ी स्टिक है या मजबूत है, उसको और तोड़ने के लिए और ज्यादा फोर्स लगाना पड़ेगा। वी हैव टू गिव मोर एनर्जी टू ब्रेक दैट। ओके, ऐसे तो नहीं होगा कि बिना एनर्जी बिना फोर्स के वो टूट गया। ओके, तो इवन कुछ भी आपको ब्रेक करना है, इवन स्टिक भी तोड़ना है या कुछ भी ब्रेक करना है, यू रिक्वायर एनर्जी। एनर्जी इन द फॉर्म ऑफ एनीथिंग, इन द फॉर्म ऑफ फोर्स, इन द फॉर्म ऑफ एनीथिंग। Okay, basically it is force. Okay, while we are breaking the stick, it require force. आप फोर्स दे रहे हो उसको तोड़ने के लिए, then it is breaking. Okay, अब उसका भी अलग अलग है। That in bonding concept it is ionization energy. In bonding condition or in bonding aspect, it is ionization energy. सबका ionization energy different है। Okay, basically ionization energy depends upon the your stability or destabilization of that bond, particular destabilization of that bond. अभी ये bond है, for example ये bond है, ये x, okay, this is your x, okay, this molecule x and this is your y, okay. अभी ये जो bond है, in between one bond is there, okay, at what threshold it is breaking, that you have to see. और ये सभी का, सभी मॉलिक्यूल का अलग अलग है। ओके, सभी मॉलिक्यूल में ये अलग अलग है। हाउ? बिकॉज एट वन मॉलिक्यूल इट इज ब्रेकिंग सपोज एट 100 किलो जूल। ओके, एट वन मॉलिक्यूल इट इज ब्रेकिंग एट 100 किलो जूल। एट अनदर मॉलिक्यूल इट इज ब्रेकिंग, for another molecule it is breaking at 120 kilojoule per mole. Okay, so your energy required for breaking this bond or ionization energy is different for different molecules. Okay, as far as different molecule is concerned, your energy is required energy is different. Okay, so definitely it will require a certain amount of energy to break. Then you are providing energy, you are providing certain amount of energy, means in the form of either heat or in the form of light. Okay, in reaction condition you are providing by heat or by light. One second. Okay, now your doubt is clear. Why it is required energy?
Yes, sir, clear हो गया।
Isn't it? Okay, Because every molecule or every bond, consider even bond, okay, even electron in the atom, suppose electron in the atom, if we want to excite from the ground state to electronic, your excited state of electronic state, okay, these two states are there. Suppose this is your ground state to your excited state of electronic state. What you require in between? If electron has to jump here, then you require energy. Okay, you require energy. Then only it will jump. Okay, it will not go as such. It will not go as such. Automatically, it will not go. It requires energy in the form of heat, in the form of light, in the form of vibration, anything, any kind of energy, depending upon the reaction. Okay, depending upon the reaction, we are providing ultraviolet rays to do the reaction. You are providing light, okay, visible light to the perform the reaction. You are providing sometimes. You are providing sometimes. एक मिनट रुकना, थोड़ा सा इशू हुआ है. टकरा के गिर गया कांच को, पता नहीं मरा है कि बेहोश है. अभी जस्ट टकराया. हाँ, टकरा. हेलो.
यस सर.
हाँ, एक पक्षी जो है यहाँ पे टकरा गया था विंडो को.
सर हेलो सर, अभी आपने सर कहा सर, मतलब कोई भी बॉन्ड को तोड़ने में सर एनर्जी लगता है.
हाँ
सर हम लोग सर बायो में सर पढ़ाया जाता है सर, ब्रेकिंग डाउन ऑफ शुगर सर, इसमें एनर्जी तो रिलीज होता है सर, इसमें क्या कर
एक इसमें चीज है जैसे कि बॉन्ड ब्रेकेज और बॉन्ड फॉर्मेशन. It is happening in one reaction. Then you have to provide the energy. Okay. While forming your bond, okay, while forming bond, what it will release the energy. While forming bond, it will release the energy. Means it is that particular area of your reaction or that particular condition of your reaction, it is exothermic. It is exothermic because it is forming the bond. Means it is stabilizing. It is stabilizing. Okay.
Yeah.
For if your bond is forming, means initially what it was unstable molecule, or at threshold level it is unstable state. In that condition, it is level of energy will be high or low. At the level of threshold energy or at the point of threshold in transition state, your if your transition state is like this, okay, you can see here, okay, this one, can you see?
Yes, sir.
Yeah, okay, this at transition state or threshold point, your energy will be high as compared to your AB, means starting material, and your product A.
Final.
Yes, it will be high, right? It is high. So from that energy, means your energy diagram or energy profile diagram itself shows the energy intensity or energy state, whether it is high, low, as compared to your product or starting material. If you see this transition state, it is looking at your highest most peak. Okay, it is highest peak in the whole energy diagram. So it is in suppose if you want to reach this level, okay, this level A to B, if you want to reach this, you require energy or you will release the energy. What will happen?
Just इसका उल्टा हो जाएगा.
You require energy, right? You require energy. But while if it start down, okay, from this side to, not in product side, but if it start to down at right hand side, you can see the energy. Okay, if we compare this AB and A plus BC and your transition state, which is the lowest in energy or which is the lower in energy? Which one?
Product, sir.
A product, right? That means your product will form. Okay, that means your product will form in comparison with your starting material. In comparison with the starting material. In that condition, if this is the condition, this is the condition, it will release the energy. Okay, this much energy, okay, this much energy, it should release. Then only your product will form. Isn't it?
Yes, sir. Yes, sir.
Okay. When if suppose I have energy, some energy, okay, and at excited state level, and if I want to become stable, then I have to lose that energy. I have to lose that energy, then will be stabilized. Okay, same thing in the molecule itself. If molecule required high energy to get the transition level, that condition you required energy to start the reaction. But after reaching transition state, it will decide whether your product energy is less and your starting material energy is less. Then if starting material energy is less, then it will go backward. Okay, it will go backward. Or if it is your product energy is less, then it will go to the forward, and you will have the product in hand by losing energy. And losing energy means it is exothermic. Okay, what kind of energy you have given? If it is heat, then you are in the form of heat. Generally, in the form of heat, your product will lose the energy, and you will find the energy like you will find the flask has little bit warm. जैसे कि, for example, आप NaOH एंड वाटर का रिएक्शन करते हो, आयनाइजेशन. Okay, NaOH and water. If you take both, what will happen? Ionization. Starting initially, you have to stir it. Means you require energy. Okay, you have to stir it. Okay, at transition state. Okay, at transition state means before the ionization. Okay, before the complete ionization, but as much as the weaken of bond. जैसे वीक होगा बॉन्ड, जैसे Na प्लस Cl माइनस होगा, या Na प्लस OH माइनस होगा, या Na प्लस Cl माइनस होगा, एट दैट कंडीशन you required in condition of NaOH. Okay, in that condition what will happen? You require cool. You have to apply ice bath to the flask. Ice bath to the flask. Then it will absorb the energy. Then it will absorb the energy which is released by the Na plus and OH minus ions. Na plus and OH minus ions in ionization reaction. In ionization reaction. Same इसके उल्टा, इसके same उल्टा NaCl का. Okay, at NaCl what is happening? NaCl curve is opposite. NaCl यहाँ पे आपका NaCl है और यहाँ पे आयनाइजेशन अगर आपका आता है तो यहीं पे ऊपर में ही है NaCl. In that condition, while stabilizing that, you required heat. You required heat. जैसे कि for example, अगर आपने NaCl लिया, कॉमन साल्ट लिया, ओके, कॉमन साल्ट लिया और उसको आप इवन कॉमन साल्ट लो, दैट इज इनऑर्गेनिक मटेरियल, इवन आप शुगर लो. ओके, शुगर, एवरीबॉडी नो शुगर, राइट?
यस सर.
Sugar, what is the form, whether it is organic or inorganic?
Organic
Material.
Organic, sir.
We can take both example, inorganic as well as the organic. Suppose take NaCl or your sugar. In that condition also, if you dissolved in water, suppose 1 glass you have taken water and you are dissolving NaCl by 1 spoon, by again second spoon, by third spoon. Okay, at certain point what will happen? What will happen?
Saturation आ जाएगा सर.
Saturation will occur, right? Correct. Saturation will occur at that point. Again, if you give temperature to that, if you give temperature to that, what will happen? It will reach to the maximum saturation level. Okay, in boiling also, in boiling water or hot water also, you can dissolve maximum amount of NaCl, as well as you can dissolve your sugar in boiling water or hot water as much as possible, or you can make saturated. Okay, जैसे मैंने एक उदाहरण जैसे दे रहा हूँ, इसी का मैं क्लियर करूंगा. और कि अगर आपने NaCl लिया और NaCl ऐड किया आपने नॉर्मल वाटर में, ओके, नॉर्मल टेम्परेचर जो है रूम टेम्परेचर में आपने ऐड किया, और इफ आई अगेन हीट इट, ओके, सैचुरेशन पॉइंट आया. सैचुरेशन पॉइंट आने के बाद उसको हीट किया फिर से, ठीक है, उसको फिर से हीट किया. हीट करने के बाद और मैंने NaCl या शुगर ऐड किया, तो उसके बाद भी और शुगर और NaCl जो है डिसॉल्व होगा. और क्या होगा? डिसॉल्व होगा. क्यों होगा? क्योंकि हमने उसकी मैक्सिमम सैचुरेशन पॉइंट जो है आयनाइजेशन की वो रीच करेंगे उस शुगर पे. ठीक है, मैक्सिमम आयनाइजेशन पॉइंट जो
सकते हैं कि सर इससे ऐसा बोल सकते हैं कि मतलब टेम्परेचर बढ़ाने पे सॉल्युबिलिटी इंक्रीज कर रहा है.
सॉल्युबिलिटी इंक्रीजेस कर सकता है क्योंकि कर ही रहा है वो. ठीक है, ऐसे बोल सकते हो. लेकिन ये हो गया एकदम जनरल टर्म में, ये हो गया कहना कि एकदम जनरल टर्म में कि सॉल्युबिलिटी इंक्रीजिंग. बट बेसिकली व्हाट हैपन, यू आर रीचिंग टू द मैक्सिमम लेवल ऑफ सैचुरेशन. ओके
यस सर।
अब
Okay.
रीचिंग, अभी बॉइलिंग वाटर हो गया, बॉइलिंग वाटर के बाद अगर आपने NaCl डालना बंद नहीं किया और आपने कांस्टेंट रखा 1 ग्लास ऑफ वाटर और उसमें आप जो साल्ट स्पून है वो ऐड करते जा रहे हैं, एट दैट कंडीशन आल्सो सैचुरेशन पॉइंट विल कम, at that point also your saturation point will come, but that will be the last point. Okay, so saturation depending upon the solvent, ये solvent to solvent saturation point of one substance or one solute, it is depending. Okay, ये क्या होगा, saturation point आपका अलग अलग substance का अलग अलग solvent के साथ अलग अलग होता है, ये पता है आपको?
यस सर, may differ.
Right, it will differ by changing the solvent or by changing the solute.
Yes,
अगर आपने सॉल्यूट चेंज किया, NaCl की जगह आपने शुगर लिया, तो भी वाटर मैंने कांस्टेंट कर दिया, जैसे सॉल्यूशन जो है, वाटर जो सॉल्वेंट जो है मैंने कांस्टेंट कर दिया 1 ग्लास ऑफ वाटर, ओके, और 100 ml ऑफ वाटर, और मैंने ऐड किया एक 100 ml वाटर में सपोज 4 टेबल स्पून जो है, एक टी स्पून जो है मैंने ऐड कर दिया NaCl, हो सकता है उतना इसमें शुगर ना हो, okay, suppose in gram scale, suppose 20 gram of sugar can be dissolved or can be soluble in the 100 ml water. सेम चीज अप्लाई होगी क्या शुगर के लिए?
नो सर।
सेम चीज अप्लाई होगी क्या?
नहीं सर।
हाँ, तो that depends upon the different solvent as well as the different solute, and your condition may differ as far as your solvent concern, as far as your solute concern. ये basically क्यों हो रहा है? That we have to understand. It is basically happened due to the molecular structure. It is happening due to the your ionization structure. Ionization, when NaCl will ionize, NaCl and NaOH both will ionize at same energy? No. Okay, ionization energy of NaOH is different, ionization energy of NaCl is different. Okay, so you cannot say that ionization energy of all the molecules are same. Okay, it is different. Okay, it is different. So that the solubility product of each solute also will find different. Okay, also it will become a different. That will make your reaction, whether it is forward direction, whether it is backward direction, whether it is exothermic or whether it is endothermic. Okay, you can see here the amount of energy required to break the bond. Okay, that is X energy is there. Okay, that is X energy, or that is threshold energy, or we can say your activation energy to break the bond. Okay, at that condition what will happen? A dash dash B dash dash C will miss, it will your delta negative at both the sides, and it shows your B. Okay, like suppose if it is magnesium hydroxide, okay, magnesium hydroxide, okay, that we can show here like this. Okay, but magnesium hydroxide, it will become a same charge. Okay, it will become a same charge. Similar means your delta negative at this side and delta negative at this side, it will be same. But if you replace that ligand, if you replace the counter anion, in that case your delta negative at this side and delta negative at this side will be different. Okay, that also will tell you which bond will break first. Okay, either this or either this. Okay, if we compare bromine, iodine, chlorine, Okay, from your carbon, which will break first?
Iodine, sir.
Iodine. Why?
Sir, this is good living group.
Good living group. That is concept of living group. But basically, it is your ionization energy. Okay, basically your ionization energy or your iodine is less attached. Your bond is very weakened.
सर
Okay,
तो
why it is good
स्ट्रेन
living?
भी रहेगा ना सर वहाँ पे, हेनरी का स्ट्रेन भी तो आ जाएगा ना वहाँ पे
Hendrix
आयोडीन
strain
में,
is there.
बल्कियर
In that condition, so many aspects are there. But in comparison with the strengthening or weakness of the bond, if we consider, जैसे कि हम दो चीजों को ध्यान में रखेंगे यहाँ पे दो चीजें हैं आयोडीन के केस में, ब्रोमीन के केस में, या जो भी हेलाइड है इसके केस में. Okay, ionic radius also will increase. Okay, ionic radius will increase, bond strength your bond strength decrease. This is your periodic properties. जैसे जैसे आप फ्लोरीन to आयोडीन आओगे नीचे in the group, if you go from first to down, okay, from top to bottom, if you go, your ionic radius will increase and your bond strengthness will decrease, so that your bond is very weakened. क्यों? क्योंकि यहाँ पे आपका आयोडीन की साइज बहुत बिग है. ओके, आयोडीन साइज इज वेरी बिग. ओके, एंड यूर जो होल्ड है इलेक्ट्रॉनिक सिस्टम पे जो न्यूक्लियस का होल्ड है, या होल्ड को कहेंगे हम, जो पकड़ है, वो उतनी लास्ट जो इलेक्ट्रॉन है, आउटर मोस्ट जो इलेक्ट्रॉन है, आयोडीन की केस में उतनी नहीं है. When we compare with the chlorine, when we compare with the chlorine, when compare with the bromine also. क्यों? क्योंकि आयोडीन is bigger than that. Okay, तो आपकी ज्यादा पकड़ने, तो then definitely what will happen? The bond will break faster. Okay, bond will break faster. तो ये concept होना जरूरत है. ये पता है that you should know first which is living group. Okay, good living group. Which one? Out of fluorine, bromine, iodine, chlorine. If we arrange the living group, okay, good living group, if we say, then it will be arranging in order of fluorine to iodine. It is increasing. Okay, living group capacity or living group nature of halide, it is increasing from top to bottom due to your nucleus hold to the outermost shell, because your nucleus radius of the nucleus is increasing, your shell are increasing. Okay, outermost shell is too far from your nucleus of the atom, so nucleus cannot hold the outermost electron as much as your bromine or your chlorine, because it is there near, वो पास में है न्यूक्लियस के, तो न्यूक्लियस उसको ज्यादा होल्ड कर पाएगा. आयोडीन के केस में नहीं है. then so that it is good living group. Later on, which one good living group? Then bromine, then chlorine, then chlorine. Okay, so as far as your periodic property is concerned, we should aware about your ionization energy properties. Okay, your strengthening of bond properties, bond character properties. Again, if we have single sigma bond, and you have pi bond, double bond. Okay, which one is the difficult to break? Which one is required more energy?
सिग्मा बॉन्ड.
Pi bond, right? Pi bond requires very less energy, because pi means only one bond. I am saying. Okay, if you consider two bonds, between the acetylene or ethene, one bond breakage, pi bond breakage is very easy. Okay, pi bond breakage is very easy in comparison with the sigma bond. Sigma bonds. Okay, and both the bond if you want to break pi including sigma, pi and including sigma in comparison with sigma, then your pi and sigma bond is stronger. Means double bond is stronger than your sigma bond because it is only one bond. Okay. Then also you can understand the distance between these two bonds. Okay. Sigma bond distance as well as your pi bond double bonded carbon distance. Double bonded carbon distance is shorter than your sigma bonded single bonded structure. Why it is so? Because it is weaker. Okay. In comparison with double bond. Okay, both the bond if we consider, then it is weaker. Your sigma bond is weaker. But if you consider the pi bond and sigma bond separately, pi bond and sigma bond separately, then pi bond, breaking of pi bond is very easy in triple bond and in double bond. It is very easy. Only breaking the pi bond. Okay, so that we can do addition reaction. Okay, easily, very easily we can do addition reaction over the ethene, over the acetylene. Okay, we can do easily. Means not much energy is required as your sigma bond cleavage, as your sigma bond cleavage. So that one can get the idea behind your bond energies as well as ionization energies of the molecule and atoms. Okay. Now you can see here. Okay. Now you can see here your this product is there. Okay. This is your product and this is your transition energy or transition state. Visual state. Okay, what will happen if your starting material energy is lesser than your product? Your delta H is here. Your delta H is endothermic. Positive. Okay, it is positive. Yes. It is positive. Then it is endothermic. Okay, in earlier it was negative. Okay, negative. So it is exothermic. Okay, so it will define the reaction condition also, whether it is exothermic, whether it is endothermic. Also, it will give the energy required for threshold, means at which temperature. ऐसा नहीं है कि सभी reaction एक temperature पे होते हैं. Some reaction requires room temperature, some reaction require cold temperature. Okay, even in minus degree, minus temperature, minus 20, minus 50, minus 12, like this. When there are requirements of different reaction condition, you can see various reactions that occurs in minus temperature also. Okay, in minus temperature also we can do or we can carry it out the reaction. But in some reaction, we require the energy, we require to provide the heat, we require to provide the light to occur the reaction, to perform the reactions. Okay, here it is exothermic. You know exothermic and endothermic concept. Okay, now yes. Is it very much clear to all? Now what is endothermic and what is exothermic? Now next time nobody should confuse regarding your endothermic reaction and exothermic reaction. ठीक है, सभी को क्लियर है? Yes sir. Okay. Yes sir. Yes. Starting material energy and your product energy is comparison with the starting material. It is less. Okay, it is lower than it is exothermic. Okay, and when it is higher or positive, delta H is positive, then it is endothermic. Means your delta H will tell about your means enthalpy. Basically, enthalpy will tell about the reaction type, whether it is endothermic or whether it is exothermic. Okay, so another
ट्रांजिशन
one
स्टेट पे कुछ कमेंट कर सकते हैं कि सर ट्रांजिशन स्टेट में बॉन्ड फॉर्मेशन और बॉन्ड ब्रेकिंग जो होगा वो साथ में होगा या फिर पहले बॉन्ड फॉर्मेशन हो जाएगा फिर बॉन्ड ब्रेकिंग होगा?
1 सेकेंड, पर्टिकुलर रिएक्शन के बारे में बोल सकते हो एक एग्जांपल? इस केस में
क्वेश्चन रिपीट करना। रेस
क्वेश्चन बताओ फिर से।
सर क्वेश्चन ये है कि ट्रांजिशन स्टेट में बॉन्ड फॉर्मेशन और बॉन्ड ब्रेकिंग जो होता है वो साइमल्टेनियसली होगा या फिर पहले बॉन्ड फॉर्मेशन होगा फिर बॉन्ड ब्रेकिंग होगा?
अगर तुम पहले के स्लाइड देखे हो, पहले के स्लाइड में देखो, पहले मैं वापस जाना पड़ेगा मेरे को। आई थिंक दिस वन।
सेमी टाइम में होता है सर।
एक मिनट, somewhere I have discussed that, right? Can you see this? Can you see this bond
Yes, sir.
making and bond breaking mechanism? Have you attended this class? ये
यस
क्लास अटेंड किए थे?
यस सर।
हाँ, तो इसमें अगर कोई रिएक्शन है एक्स वाई जेड, कोई भी रिएक्शन है, फॉर एग्जांपल यही रिएक्शन है, ओके, हम इसी रिएक्शन को देखेंगे। तो इस रिएक्शन में जैसे यहाँ पे हमने मेंशन किया था, देयर आर टू काइंड्स ऑफ बॉन्ड मेकिंग एंड बॉन्ड ब्रेकिंग सिस्टम. वन इज concerted, means what you are saying, that is simultaneous. Okay,
Yes.
one is concerted, simultaneous or in one step reaction. What is that? No matter how many bonds are broken or formed, उसका कोई मैटर नहीं है,
नहीं कर
but it will occur in one step and simultaneous manner or concerted manner. एक ये टाइप है
Yes.
रिएक्शन का, एक ये टाइप है. Further, one more type is there, that is stepwise reaction. Same thing will apply no matter how many bonds are broken and formed, but at one step it will stop, or at one step it will hold the reaction in the form of adduct, in the form of intermediate. Okay, and further you can add some reagent or any material to perform the further reaction, and you will get the product. You will get the product. That is called stepwise reaction. अब that is stepwise reaction मतलब क्या है? Stepwise reaction मतलब हो सकता है 2 स्टेप की हो सकता है 4 स्टेप की हो सकता है 10 स्टेप की हो सकता है 100 स्टेप की हो. आपका कोई कोई ड्रग मॉलिक्यूल है, फॉर एग्जांपल कोई ड्रग मॉलिक्यूल है, देयर आर 50 स्टेप्स बिटवीन योर इनिशियल स्टार्टिंग मटेरियल टू योर डिजायर्ड प्रोडक्ट. ओके, डिजायर्ड प्रोडक्ट और फाइनल प्रोडक्ट, वहां पे 50 स्टेप है. ऐसा है कि एक स्टेप से तुमने ए टू बी किया, बी टू फिर सी किया, सी टू डी किया, और फाइनल में तुम्हारा प्रोडक्ट मिला, डिजायर्ड प्रोडक्ट मिला. दैट इज कॉल्ड स्टेप वाइज रिएक्शन. इन ड्यूरिंग कोर्स आल्सो, एक रिएक्शन में भी, एक पॉट के रिएक्शन में भी साइमल्टेनियसली दो रिएक्शन होते हैं. फॉर एग्जांपल यहाँ पे मैंने यहाँ पे ये देखा, ये देखो, यहाँ पे कार्बोकैटायन फॉर्मेशन. ओके, कार्बोकैटायन फॉर्मेशन वी हैव सीन, बट इट विल स्टॉप एज सच. ये यहीं पे स्टॉप होगा क्या? ओके, वन योर butanol, okay, tertiary butanol is started reaction, okay, by reacting with some nucleophile, okay, by some nucleophile like Ki or anything, okay, KCl or something. Okay, if you do that reaction, what will happen? Okay, your this hydroxy group will release. Okay, it will release from your carbon, and your carbon will get carbocation state. Okay, this is your one intermediate. This is your one intermediate in SN2 SN1 reaction. That we will see what is SN1, what is SN2 substitution reaction types. Okay,
Yes, sir.
but this is your one step within one reaction. इसमें और कुछ कर रहे हैं कि नहीं, but next you will add any nucleophile over here and that nucleophile will attach over here. Means basically what you are doing, you are substituting this OH group by another, okay, another nucleophile, and you will get the product. That is stepwise. Okay, now you have understood.
Okay, yes sir, thank you
सर
sir.
लेकिन ट्रांजिशन स्टेट सामंजस्य में होगा, एक ही साथ में होगा सर।
Yes,
इनका सर ये सर पूछ रहे थे कि ट्रांजिशन स्टेट में बॉन्ड फॉर्मेशन एंड बॉन्ड मेकिंग और बॉन्ड ब्रेकिंग एंड बॉन्ड मेकिंग मतलब कैसे होता है, तो उस एक साथ होता है।
in a transition state, at one step reaction it will happen same time, concerted mechanism. At one stage it will happen in one time, or it is simultaneous. Okay, you can see this reaction example. Okay, here you have determining the delta H for the following reaction. Okay, what is the reaction? Your tertiary butyl chloride, when reacted with the water in presence of base, what you will get? You will get alcohol, tertiary butyl alcohol and HCl. Calculate the bond broken energy and bond form energy. Okay, then you have to go to this delta H kilocalorie per mole. It will tell about the bond breakage of C2Cl, carbon Cl bond. When it will break, it requires energy plus 79. Okay, it requires energy plus 79, and hydrogen and your OH group from the water, it requires 119 kilocalorie per mole. Kilocalorie per mole means your total energy plus, means it is in required. You have to break this bond, then it is required energy plus energy 198 kilocalorie per mole. Okay, this energy you require to break this bond, break these two bond. Okay, then bond formation. Bond formation, if you go to the bond formation, then delta H kilocalorie per mole, this OH required minus 96. Okay, OH bond formation require minus 96, means it releases minus this much energy, it is released, and HCl minus, it shows means minus shows means ऐसा थोड़ी कि वापस दे रहा है, it is releasing the energy. Okay, HCl bond कब break होगा? When it releases the energy of 103, then total of this bond breakage, bond forming energy is minus 199, 199 kilocalorie per mole. If you consider both these two, okay, your delta H come in one step, and in second step you will have minus 1 kilocalorie per mole. Okay, because your delta is negative value, the reaction is exothermic, and energy is released in this reaction. Energy is released in the reaction. The bond broken in the static material are weaker than the bond formed in the product. Means overall we calculate the energy of this bond cleavage and bond formation. It will be calculated like this. Okay, your delta H will be calculated like this. Okay, so ultimately you will get the answer like this, minus 1 kilocalorie per mole for this reaction. Particular for this reaction, your answer is that reaction shows the minus 1 kilocalorie per mole overall. Okay, so that it is exothermic reaction. Your delta is negative, so it is exothermic reaction, and the bond broken and static material are weaker than bond formed in the product. Okay, so it is stable. Okay, now it is stable product. Now due to this energy, due to this much of energy, 1 kilocalorie more per mole, only that energy will inhibit or will stop the backward reaction. Will stop the backward reaction, means reversible reaction will not be possible due to 1 kilocalorie per mole energy. ओके, समझ में आया?
Yes, sir.
Okay, so now we will stop here. In next lecture we will see about the different kinds of reaction, as well as, okay, we will discuss about the different kinds of substitution reaction, elimination reactions, and its mechanism.
Okay, thank you, sir.
Thank you all of you.
Thank you, sir.
Thank you, sir. अटेंडेंस हो गया ना सर?
हाँ हो गया। मैथ की क्लास का लिंक आ गया है।
अटेंडेंस हो गया सर? अटेंडेंस हो गया छोटू?